Right, at this point, I just want to talk through a couple of examples because sometimes it's easy for students to get too involved in the problem and really stop thinking so much about what they already know about the problem. So we're going to look at a couple of examples, ones that we actually talked about earlier, to see what your intuition would tell you just about the context that we already know. So for our first example, we were looking at the students' overall percentage in the class, and we decided that was our y variable, and the number of classes that they missed being our x variable. So let's just think about, before I even get the data, what would I expect to see? So our x is our number of classes missed, and our y is our class percentage. All right, so let's think about what we would expect to be. So as we move to the right, so as someone misses more classes, what would you expect to happen to their grade in the course? Well, I would tend to think that if you miss too many classes, that's probably going to have a negative impact on your grade. So I'm going to expect to see this negative relationship happening. But let's write that out to make sure it makes sense. So I would expect as students miss more classes, that's us moving to the right there, that this would have a negative impact on their grade. So then what we're trying to say here is, so generally, as number of classes missed goes up, I'm expecting their grade, or that class percentage, to go down. So before I even look at this data, I'm already going to expect to see this negative pattern between my x and y. So this already gives me then an idea of what to expect before I dive further into the problem. I'm expecting to see now a negative relationship on my scatter plot. I'm expecting a negative value for slope as I start moving further and further ahead in this module. All right, for our second example, we're seeing if a house has more square footage, how that affects the price of the house. So our square footage was our x, and the price was our y. And so same idea here. What would you expect to happen as square footage got bigger? So as square footage increased, that kind of think that my house is getting bigger. So what would I expect to have happen to price? Well, I'm going to expect price to probably go up. Generally, bigger houses cost more money. Right? I would expect larger houses to cost more. So then generally, as our square footage goes up, I'm going to expect my price to also go up. Now a little note, the reason why I use the word generally here is these are patterns I expect to see, it doesn't mean it's going to be true for every 2 points I compare. So for example, down here, if I have 2 houses and one happens to have more square footage than the other, that's not a guarantee that that house will cost more than the other house. Right? There are other things that impact the price of the house. Square footage is just one of those things. So this is my general pattern I expect to be true, not necessarily true for every pair of houses that I would look at. So this now allows me to have an idea of what I should expect before I dive deeper into the problem and get a little bit more algebra-y on y'all.